Okay, so we'll go through the steps for this question, then every question is kind of similar. So whenever you get a hypothesis testing for binomial, just say x, b, and then the number of trials and the probability of success. So the number of trials in this question is 20, and the probability of success is 0.3. So that's your distribution. And just say let P be the probability that, in this case, the bead is gold. And then this bit's optional, but I'd recommend you do it. Sketch it out, because then you can see what the distribution looks like, and it makes it easier to visualize. So if you have the CG50, it will sketch it for you anyway. But all you need to do is work out the mean. The mean is n times p. So that's 20 times 0.3, which is 6. So this is 6, and then on the side, the probability just gets lower and lower. Yeah? Now, the reason we do this is we can then write the test statistic. The mean is what you'd expect, so somewhere close to 6 gold beads out of 20. And the test statistic is what actually ended up happening. The question says that the person found just 2 gold beads in the sample. The reason this is important is because we know that 2 is like over here, so it's a left tail test rather than a right tail or two tail test. The null hypothesis was that the p is 0.3. Based on that test statistic, they're trying to suggest that the probability has decreased. So we're going to say p is less than 0.3. And all you ever do is you end up working out the probability of that left tail or of that right tail based on the test statistic. So we're just looking for these probabilities. So we're going to say probability that x is less than or equal to 2 equals, we go in our calculator, binomial CD, and we put all the stuff we said. N is 20, P is 0.3, and X is 2 on the left tail. And we get 0.0355. Okay, now any questions so far? So now we need to decide whether this means that we should reject HO or accept HO. So 0.035 is less than 0.05, which was the significance level. This is a very low probability, meaning that something weird happened. There's enough evidence based on this weird test statistic to suggest that we need to update our probability, because the probability should be lower. There's no way that it's 0.3 chance, but we're getting a test statistic of only 2. So because it's less than the significance level, reject HO or accept H1. There's sufficient evidence to suggest P is lower. You can write that in full words, but we said it earlier. So we're basically saying, based on the test statistic being so low, there's sufficient probability that there's a sufficient chance that the probability has decreased. Sufficient evidence that the probability has decreased. Okay. Another one. So, Asan, do you want to do it out loud with me?
Okay.
So what's my distribution?
You'd have 10
Yep.
for N and 0.4. 0.4 for the probability that the customers book their tickets through agents.
Yep, and then let P be the probability. One sec. Cool.
Then
And then we need to, this is the bit that you don't have to do, but I think is important. So just tell me the mean and tell me the test statistic. How do I get the mean?
is that just when you put it in the calculator? Then
No, just use the formula n times p. So it's 40% times 10.
4.
Yeah. Do you get that? Do you understand it? It makes sense, right?
Not really.
So there's, well, you should just memorize. It's in the formula book, but just memorize. The formula for the mean of a binomial distribution is n times p.
Okay.
But also just logically,
Oh,
your
you're like
sample
putting
size
into
is
real
10
terms.
and it's 40% of 10. So 40% of 10 is 4, right?
Yeah.
Cool.
Okay.
What's the test statistic?
1.
Yeah, exactly. So it's on the left tail, isn't it?
Mm-hmm.
So that's 4, 3, 2, 1, 0. And we're just working out this left tail over here. So what is it that we're going to work out? The probability that x is less than or equal to 1. Do you get that? Do you have any questions about that bit?
Nah.
Cool. So all you're doing, you're working out the test statistic and even further extreme outcomes on that tail.
Mm-hmm.
Cool. And then I'm just going to put n as 10, p as 0.4, and then x as 1. And then I'm going to get 0.0464. 0.0464 is less than 0.05. So what would I say now?
Would you say would you have written H0 and H1 before?
Sorry, yeah, I should have done that before as well. I'll just write HO is P equals 0.4 and H1 as P is less than 0.4 because it says decrease.
Yeah.
Cool. So then would you reject HO or accept HO?
Would you...
Again, there's two ways to do it. You can memorize it when it's really low, when the probability is lower than the significance level. You can memorize that you need to do something, or you can try your best to understand it. So if the probability is low, basically what we're saying is the probability of this happening is really, really low, yet it still happens.
Okay.
That means our model was wrong in the first place. Yeah? So if our model is wrong, which hypothesis is wrong?
H0.
Exactly. Reject
Okay.
H0 because it was overestimating how many people booked their tickets through agents. According to that distribution, 10 0.4, they wouldn't have expected this outcome, but this outcome has just happened. So it must have been wrong, right?
Yeah.
Evidence to suggest that the probability of using an agent is actually lower than 0.4. Because we were expecting 4 out of 10, but they got 1 out of 10, right? And that probability was less than 0.05, so it's like, okay, we need to update our model.
Okay.
Cool.
So you would write the XB thing as you'd set N to 30 and P to 0.25.
Cool. And then what two things do I want to write down?
The test statistic and the mean.
Perfect. And what are they?
Would you do 0.25 times 30 for the mean?
Perfect. So it's a quarter of 30, which is 7.5.
And then the test wait, what would you? I don't get that, the test statistic bit.
Yeah, that's a good question. Basically, it's the bit that You know how we're expecting 7.5 people to buy crisps? So
Yeah.
we're just going to say let P be the probability of them buying cheese and onion.
Yep.
So we're expecting 7.5. The test statistic is the bit that the person found, the shop owner found. So what did the shop owner end up finding?
4.
Exactly, that's the test statistic.
Oh, okay.
So now that's your 7.5. 7, 6, 5, 4, and all these. So this is a left tail test again. Do you get that? Do you have any
Yeah.
questions? Okay,
No,
cool.
I get that. Yeah.
Cool. And then I forgot last time. HOP equals 0.25. H1 is what?
P is it less than or equal to 0.25 or just less?
We never do equal to. We're just trying to see if it's changed. So
Oh, okay.
it would have been if it's decreased or not. Cool. And then what do we work out?
Wait, is this where you like plug in the calculator?
Yeah.
Like,
What are we going to put in the calculator?
P is 0.25, N is 30, and X is would wait, X is 4, right? Or
Yeah, but why are we doing that? Basically, think about it this way: we're trying to work out the probability of the test statistic, or well, think about it this way, right? You've got all these outcomes.
yeah,
Out of 30 customers, you could have 0 customers get cheese and onion, 1 customer, 2 customers, 3 customers, 4 customers, 5 customers, 6 customers, like up to 30. That's all the different number of people who could buy cheese and onion, right?
yeah,
We just want to check the test statistic and the more extreme outcomes on that tail, just
yeah.
to see how rare it is that any of those things happen. So we're going to
Mm-hmm.
work out, we need to say we're working out the probability that x is less than or equal to 4.
Yeah,
Okay, cool. And then, yeah, like you said, you just put those numbers in your calculator. We get 0.0979. 0.0979 is more than 0.05. So was it very, very rare or not that rare to have 4 customers buying cheese and onion?
it's not rare, right?
Cool. So then do we need to update HO, or was HO pretty much fine?
It was fine.
Exactly. So do not reject. You can say do not reject, or you can say accept HO. It's up to you how you word it. Not insufficient evidence to suggest that the probability has actually decreased. So basically, we would have expected 7.5 people to buy cheese and onion. Only 4 people bought it, but 4 people is not that far off from 7.5 according to our model. It's not like something significant to worry about. So we don't need to update our model. That's what the topic is saying.
Yeah,
Cool.
makes sense.
Perfect.
The thing is,
Yep, perfect. So X, B, N, P. N is 20. P is 0.35. And then what do I work out?
the 35% of 20.
Yeah, and what's that called?
Is it the test statistic?
No, that's the mean. Right? Mean is NP.
Mm-hmm.
So what's the mean? So,
It's 0.35 times 20.
yep, cool. So 7. And then the test statistic?
3.
Yep. And we have to say, let P be the probability that they want vinegar.
Mm-hmm.
Cool. And then what's your sketch? Like in the middle, we're going to put 7. And then that's your 3. And we're working on the left tail, right?
Mm-hmm.
Okay. So what's H0?
It is,
Yep. And H1?
less than 0.35.
Cool. And then we work out this stuff that we highlighted, right? So what are we going to work out? Probability that X is?
3 or less.
Yeah. And then we get 0.0444 when we type X as 3 in binomial CD with N as 20 and P as 0.35. And then what do we say?
That it's less than
0.05.
0.05.
Cool. And then what
So
do we
do we reject it?
Reject which one?
The null,
Yep.
because there's not enough evidence.
No, there is a lot of evidence to
Oh, there is enough
show
evidence.
that what has it proven?
It's lower than the significance level.
Yeah, but in everyday language, in terms of the vinegar, what has this proven?
Oh, less than 5% of people.
Less than 35% of people.
Less than 35% of people want vinegar.
Exactly. Because we would have expected 7 people to ask for vinegar, but only 3 people asked for vinegar. We knew it was like touch and go, that's why we're doing a hypothesis test. The fact that it came out under 5% is what proves that it definitely needs updating, and the owner should like reevaluate for next week how much vinegar to keep or like whatever.
Mm-hmm.
Cool. And then I would just say sufficient evidence that the probability of people wanting vinegar has fallen. Probability has fallen. Okay, perfect. So let's try this one. It's a right tail. It's the same thing, but it's on the right tail.
Yeah. So you'd write the XB.
Yep.
You'd have 20 for the sample and then 0.15.
Cool.
The mean is
Just tell me what to work out. I'll do it.
20 times 0.15.
Yep. 3.
Okay. And then that's 8 for
Perfect. And then this is
where
on the
it's P
right.
is the probably of non-smokers. Yes, to the right. So the null hypothesis is, oh my god, null hypothesis is going to be P equals 0.15.
Yep.
And then the other one, P is greater.
Yep.
And then you plug it in on the graph, on the calculator.
So what am I going to work out in the calculator this time?
You're going to work out.
So this is 3.
And
then this is 8. So I'm working out this bit on the right of 8.
Yeah.
So what am I going to work out? Probability that X is
greater
than or equal to?
Greater than or equal to 8.
Exactly. And then if you have the CG50, you just put 8 and you put right tail. And then if you have the CG 991 or whatever, you put 7 and then you have to do 1 minus the answer. So you get 0.0059. 0.0059 is less than 0.01. So then that's a very low chance of the of having 8 non-smokers. So what should we do? Should we update our probability or keep it the same?
Would you keep it the same?
So whenever the probability is really low, it's suggesting like the model was wrong. Remember that?
Okay.
So what do we do?
You have to update it. So you'd say there's sufficient evidence that the probability of finding a non-smoker is a lot lower.
It's increased.
It's increased.
because it's a right tail test this time. So we
Okay.
thought we were expecting 3, but we found 8,
Oh,
didn't we?
yeah.
Yeah, and we were testing if it's increased, and we think it has now, because if it was our model, if our model was correct, based on that model, there's only a 0.59% chance of this thing happening. However, it actually happened. So if we're testing in terms of a 1% significance level, that's evidence that our model was wrong.
Okay.
Yeah. The only thing that's confusing is the significance level, why they pick 1 or 5 or whatever, but that's like up to the statisticians. But in terms of us, we just need to know whether our probability is extremely low or not that low, because then we can figure out if our model was wrong or right. Yeah.
Yeah.
Neeraj, try this one with me.
So n will be 40 and that'll be 0.45p.
Yep.
And then the mean will be 18.
Yep.
And then the test statistic would be 23.
Yep.
And then
And then we're working out this bit, right?
yeah,
Cool. So what should I work out? Px.
is greater than greater than would it be greater than 23?
Greater than or equal to 23.
Okay.
Yeah.
Wait, why is it equal?
So we look at we're expecting there to be 18, but there's 23. So we just check the probability of it being 23 or 24 or 25 or 26. We always check the test statistic or an even more extreme outcome.
Oh, okay.
So like, what would be considered weird? Would it be 22 or would it be 24? It'd be 23 and higher, right?
Yeah.
So those are the ones we work out.
Mm-hmm. And then you just plug everything in your calculator from there.
If you have CG50, you just put 23 and right tail. What do you do in your one? Because you'd have to do 1 minus something, wouldn't you? So what number would you put in your calculator?
Carla, I'm not sure because I remember doing this with the CG50 in school because I used my friend's calculator, but I don't remember how to do it without it.
Okay. After this, we'll go back to the basic bit just to make sure. But for now, we just put 22. We'll do it again
Okay.
properly slowly, but you would have to put 22, which would give that, and then you do 1 minus that, because everything apart from less than or equal to 22 will be more than or equal to 23. Yeah?
Yeah.
Cool, and you get 0.0767, so you'd put n as 40, p as 0.45, and then that's quite a high probability, isn't it?
Yeah.
So is our model right or wrong?
Wrong. Wait.
Okay.
No. Wait. Test.
Basically, just remember, whenever something happens with a really, really, really low probability,
Yeah.
that's what means that the model is wrong. Right now, something normal happened. It's not that nothing to worry about.
Oh yeah. So this isn't normal.
Yeah, so
When did it? Yeah.
HO. Insufficient evidence that the model needs updating. It doesn't need updating.
Mm-hmm.
Yeah. So again, realistically, you're thinking like, we were expecting there to be 18 people asking for a wash. 23 people asked for a wash. That's not that rare according to our model. There's a 7.67% chance that would have happened. So there's no need to update our model. Our model's fine.
Yeah.
Whereas think about it this way, if 35 people ask for a wash, then the owner is bugging. Like, he needs to reevaluate. He can't expect there to only be 45% of people asking for a wash, it's going to be much higher. He needs to update his model for next weekend.
Yeah.
Cool.
It's gonna be 15 and 0.3.
Yep.
The mean is 5.
Yep.
The statistic is 9.
Yep. And there's just one more thing, that P be the probability of what?
It'd be the probability that it's queuing for more than 5 minutes.
Yep. Cool. And then on my sketch, I've got the 5. And then I got the 9 over there. So we're working out that stuff. So what should I work out?
Probability that it's 8 and then take it away from 1.
So, but what should I write first? What am I actually working out?
Oh, that it's greater than 9.
Greater than? Not just greater than 9.
Greater than or equal to 9.
Yep. Because it's always the test statistic or more extreme outcomes, right? Cool. And then, like you said, you do 1 minus that if you don't have CD50, and then you get 0.0152. 0.0152 is more than the significance level, so it wouldn't be considered that rare or that low. So what should we do?
We accept the null.
Yep. There's insufficient evidence and not enough reason to update it, considering the probability of the test statistic didn't dip below 1%, basically. Okay. So here's another one. The first steps are the same. We're just going to say XB N in this case is 20 and P is 0.3. I think it's the same as one of the other questions we did, the gold beads. Let P be the probability you get a gold bead. The mean is 20 times 0.3, which is 6. And she found 2 gold beads. It's the same question we did before, but it's 2-tail this time because it's whether or not there's evidence it's changed rather than increased or decreased. But the method's still the same. You've got a test statistic of 2. So if my mean was 6, I've got this shape. And then that's on the left. So I'm still working out everything I was in my left and right tail test, right? I'm going to say probability that x is less than or equal to 2 is 0.0355. The same thing we did before. The only difference now is we have to half the significance level. So if the question says test it at 5%, the significance level on each tail is 2.5%. It's 5% as a whole. If it's 2-tailed, it's 2.5% on each tail. So we say 0.0355 is more than 0.025. That's a bigger probability than, well, it's quite a big probability. It's not like less than 2.5%. So there's no reason that we need to suggest or think that our model's wrong. We don't need to update our model, none of that. So we say do not reject, or we say accept HO. Insufficient evidence that the model needs to be updated or that the probability has changed or anything like that. Okay, do you guys want to try this question and then I'll go through the answer in 5 minutes? Okay, talk me through it.
So I wrote the thing, XB, I wrote 40, 0.2. The mean is 8 and the test statistic is 12. And so I said the probability of X being 12 or greater than or equal to 12 is 0.2.
Cool, so you worked out P more than or equal to 12, yeah?
Yeah.
Cool, because your mean is 8, but we found a number on the right hand side, so we're just going to work out the probability of that. But then what we do is, for the benefit of the doubt, we also just add on those probabilities just in case.
Mm-hmm.
I'm not actually sure the proper reason why they do that, but yeah. And then what did you get?
So on the calculator for P, I got 0.0875.
That's correct.
But then do you half that? Or do you not half
No.
that? Do you only half the significance level?
You half the significance level.
Okay.
So you say 0.0875 is less than 0.05. Basically, the significance level is 10% in total,
Yeah.
meaning it's 5% on the left tail, 5% on the right tail. But we're just doing a right tail test
Yeah.
with half the significance level off, if that makes sense.
Mm-hmm.
So this is a reasonably high probability. So do we need to update our model, or do we keep it the same?
You can keep it.
Exactly. So accept H0 or do not reject H0. Either of them are fine. There's insufficient evidence to suggest that the percentage of seeds has increased. Yeah?
Yeah.
Perfect. Okay, moving on to critical value. I'll go through an example. Critical value is actually easier. It's just a bit long, but it's not meant to be hard. So we have X, B. So a nutritional expert believes that children ate healthier in the past. So they think the number of proportion of children eating 5 a day has decreased. So it's 0.4 was the people who were eating 5 a day. It's a sample size of 15. So if I was to do a sketch straight away, my mean is 15 times 0.4, which is 6. But we don't have a test statistic. That's the difference. There's nowhere in this that says a test statistic. So if I did a sketch of 6, yeah, all I know is the probability of it being 5 people out of 15 eating 5 a day should be lower. 4 people eating 5 a day should be lower. 3 people lower, and 2 and 1 and 0. Okay, and same on this side. But this is a left tail test, so we don't really care about the other side, but it will follow the same pattern. Okay, what we're looking for is, normally we would have got a test statistic somewhere over here, and we would have measured the probability of it. Now we're going to measure the probability of all of them anyway. So imagine if the question was giving you a test statistic, it would probably give you 2 or 3, right? So I'm just going to work out the probability x is less than or equal to 3. The probability x is less than or equal to 2. The probability x is less than or equal to 1. And the probability x is less than or equal to 0, right? So Esan, can you check that for me?
I got 0.0905
Yep.
to 0.0271.
Yep.
And then what does the E mean? Like times 10 to the minus 3, isn't it?
Oh,
It's
okay,
like
sorry. Leave it, it's fine anyway. We got our answer. Because
yeah.
what I actually needed to do was also do 4. So the probability that x, can you just change it to 4 and just do one
Yeah.
more?
0.2172.
0 point?
2172.
Okay, cool. So as you can see, if we work this out, we would not have rejected it because it was high. If this was our test statistic, we would have rejected it because our significance level was 0.1, yeah? So the critical value is x equals 3, meaning if I got 3, I would have rejected it. The critical region is x is less than or equal to 3. Basically, if my test statistic was 3 or 2 or 1 or 0, my probability would have been so low, it would have been a shock to the nutritional expert. He would have basically been able to say, look guys, I'm right, the probability of people eating 5 a day has actually gone down. It's the same as your normal questions that we did. The only difference is we're pretty much making up a test statistic, or we're checking for every test statistic one by one. This one's on the right tail. Can you guys try it before I go through it? So this is a right tail critical region test, but basically, so you got your XB, N is 20 and P is 0.1.
Yeah.
Your mean is 2 and we don't have a test statistic.
Yeah.
So that's 2. That's going to be 1. That's going to be 0. These all seem reasonable. 3, 4, 5. That's what it would look like in your CG50 when you put the numbers in and put anything. Now, we're looking for the bars that are really low because that's going to suggest, wait, if these things happen, something's wrong. So the person believes that the probability is higher. That's me focusing on the right tail.
Okay.
So obviously, if we had to guess, it would be one of these numbers over here where it will start to be low enough for us to reject it. But if we just use, like, we should go step by step, right? So we know it can't be 2 because 2 is the mean. So if it's not 2, it's going to start by 3 or 4 or 5 or 6 or 7. We just go in order from 3 onwards and do every single situation. So I'm going to say the probability that x is, because if I did 2, it would be around half. It would be 0.5 or like, it would be actually, no, even more than that. It would be a big number. So I'm going to check probability more than 3, more than or equal to 4, more than or equal to 5. I maybe don't need to write all of these down, but that's what I'm checking.
Yeah.
And eventually the probability is going to dip below the 5%. That's what I'm looking for. Okay, cool.
Okay.
Now, do you have the numbers or should I check them quickly?
No.
Okay, one sec. I'll check. So, Asan, back to your question. Once we get these numbers, this will be like a bigger number. It's going to get smaller and smaller and smaller and smaller. Now, what we're looking for is, according to our model, we're expecting 2 people. We're expecting 2 tiles to have a fault, right? So if I told you that, look, 2 tiles are going to have a fault, and in the end you checked 20 tiles and you found 3 of them with a fault, would you be like, wait, you told me the wrong probability? Would you say that?
Yeah.
No, but like, would it have been well off, or just like, because it's just a guess, right? Do you get what I'm saying?
Yeah.
So if I told you it would be roughly 2 tiles with a fault, but you got 3, that wouldn't be weird, right?
Yeah.
Cool. If I told you there was going to be 2, but you found 4, would that be weird? Not
really,
weird. Not that weird. And then what about if I told you there's going to be 2, but there was like 10 of them with a fault?
And yeah, you'd be wrong.
Cool. But exactly. So now what we need to do is we need to find when that will be 0.05 or less. That's the minute we say, that's our turning point where we say, wait, now our model was wrong. So we're just looking for when this number switches. From this point onwards, the probabilities dip below 0.05.
Yeah.
That's not something we choose. That's just what it is in stats, it's standard to test stuff at like 5% significance or 10% significance or whatever. In this case, 10%.
Yeah.
So the critical value is x equals 5. The critical region is x is more than 5, more than or equal to 5.
Okay.
Because that's the point when, if I ask you that same thing one more time to repeat it, I'm expecting there to be 2, you're expecting there to be 2 because it's a 10% chance, but
Yeah.
3 end up being faulty, cool, normal. 4 end up being faulty, cool, normal. 5 end up being faulty, not sure. 6, yeah, that's quite high, right? So we just
Yeah.
need to check by comparing it to 0.05. And then when it's
Okay.
lower than 0.05, we reject HO.
Okay.
So critical value is the first one that means we need to reject the thingy. I'll do 1 two-tailed before we stop. So for this one, I'll just do it quickly. We have XB 50 tiles and P is... Wait, is that the same question? No, it's not. Where is it? Oh, it's the same thing but two-tailed version. Cool, so 50 tiles and 0.1. We've already done the right tail, but yeah, I'll just show you how to do it on the left tail. And so we know that the mean is 5, 50 times 0.1. So out of 50 tiles, actually I think it's different. Yeah, 50 tiles, we're expecting 5. The probability of it being 4 would be lower, but remember like how I was saying, we're expecting 10% of them to be faulty. 4 wouldn't shock me if there were 4 tiles with faults. 3 tiles maybe wouldn't shock me, maybe not. 2 tiles would probably shock me. Yeah, and then 1 tile and 0 tiles would definitely shock me. So these are the ones where I'm thinking are going to be critical. Yeah, but we're going to check that. So on the left tail, my significance level for each tail is 5%. And on the right, my significance level is 5% as well. So on the left, I'm doing probability that x is less than or equal to 4, the probability that x is less than or equal to 3, the probability that x is less than or equal to 2, the probability that x is less than or equal to 1, and I'm trying to find when that number gets below 0. Wait, sorry, I think I said the significance level wrong. Wait, does it say? Yeah, it says 2.5% on each tail. So it was a 5% significance level. So I'm going to see when that gets below 0.025. Yeah. It turns out that this one was the first one that was below 0.025. So 1 is the critical value. So 0 and 1 are the critical values on the left tail. Then on the right tail, if I'm expecting 10% with minor faults, 6 wouldn't surprise me, 7 probably wouldn't surprise me, and then I'm just looking for which one would surprise me. And then whichever ones are below 0.025, that would be my critical value. So it turns out it was 10, 11, 12, up to 50. So does that make sense?
Yeah.
Cool. Any last questions?